Hello students, my name is teacher Onzere Boniface, your physics teacher. I'm a teacher by profession, a teacher in Boqol High School, teaching mathematics and physics. Today, our lesson is from a Form 1 topic, the topic forces. We understand in our previous lesson, we learned about what force is. We defined force, and we said that force is a push or a pull. When you push an object, you are exerting a force on that object. When you pull an object, that is a force in action. So basically, the simplest way of defining force is a push or a pull. When I push the desk, I'm exerting a force. When I pull it, I'm exerting a force. So force is a push or a pull. A push or a pull on an object. I may insist on something here. We have those who have some pronunciation problems, and they translate their pronunciation problems also in writing. Many times I've come across a student defining this force as a bush or a bull. I know that is a mistake in terms of pronunciation, in terms of accent, but try as much as possible to avoid this problem. I've met a case of a student pronouncing this word as a bush and this one as a bull. When it comes to writing, he also includes that mistake. So make sure you are able to differentiate the difference between a P, letter P, and letter B. So force is a push or a pull on an object, not a bush or a bull. Now, we learned that we have two categories of forces. Forces are categorized into two. We have those forces we call conduct forces. A category of forces we call conduct forces. And we said these are forces which act when two bodies are in contact with each other. These are push and pulls on objects in contact. When push and pull occurs when two objects are in contact, that is a type of force, we are calling it a conduct force. And we gave examples of conduct forces. The main type of an example of a conduct force is friction. We know friction, which type of force it is. It opposes relative motion. When I rub my hands against each other, there is always force in action. And this force which is trying to oppose my hand moving against the next or the other, it is friction force. So friction force is a type of force which we call conduct forces. Then we learned about the second category, we call them non-conduct forces. Non-conduct forces. Which forces are these? These are forces which act when bodies are not in contact. A force acting between bodies which are not in contact. Pushes and pulls within bodies which are not in contact. That is non-conduct forces. We gave examples of non-conduct forces. A good example of a non-conduct force is surface tension. A good example of non-conduct force is tension force. Now, so we must know, or as a student, you must know the two categories of forces: conduct forces and non-conduct forces. Forces which act in bodies are in contact, and forces which act when bodies are not in contact. Those are two categories of forces. Then we narrowed down and looked at examples of forces. We have so many examples of forces. And we gave a list of examples of forces. We talked of tension force, tension forces. We have surface tension. We have gravitational force. We have upthrust forces. We have magnetic force. We have cohesive and adhesive force. And so many other types of forces. In our previous lesson, we discussed about three types of forces. We discussed the gravitational force, we discussed the tension force, and we also discussed about the upthrust force. So today we shall be looking at our fourth type of force, and this force is called cohesive and adhesive forces. Cohesive and adhesive forces. We call them cohesive and adhesive, meaning they are so similar, so we cannot treat them as different forces. They are similar because they occur like in pairs. Now, what is a cohesive force? We define a cohesive force as a force of attraction between two bodies, a force of attraction between two molecules which are like. It is a force of attraction between molecules of the same kind. Molecules of the same kind. When I talk of molecules of the same kind, we are referring to similar molecules. A force of attraction between molecules of the same kind. When you talk of molecules of the same kind, what do you mean? We understand matter contains particles. And an example of a particle that matter contains, it is a type of particle we call a molecule. A molecule is a particle found in matter. Now, if I'm referring to water as my matter in this case, water is made up of particles, which we call the water molecules. And these molecules do not exist singularly. These molecules are attracted to each other. If this is a container of water, we have particles in water. These particles do not exist freely. They are attracted to each other by forces, strong forces of attraction between them. This one is attracted to this one is attracted to this one, and they form a uniform connection, a structure of molecules attracted to each other. Now, this force which is attracting one molecule of water to another molecule of water is what you are calling cohesive forces. Why? Because this is a molecule of water and this is another molecule of water. So they are molecules of the same kind. A force of attraction between molecules of the same kind, that is cohesive forces. Cohesive forces are the one which gives rise to the different structures of substances. The structure of a solid, the structure of a gas, the structure of a liquid, all those structures are different. The force which is attracting those particles, the particles of a given substance, together strongly, that force is called cohesive. So we call them cohesive forces. Forces of attraction between molecules of the same kind. The other type of force is adhesive force. Adhesive force is a force of attraction between molecules of different kind. A force of attraction between molecules of the same kind. Molecules of different kind. A force of attraction between molecules of different kind. What kind of molecules are we referring to? We have molecules of the same kind, that is cohesive force. I've talked of an example of a water molecule being attracted to another water molecule. The force of attraction between these kinds of molecules, we call it cohesive force. But we have another type of force which attracts a molecule of water and maybe a molecule of the container in which the water has been placed. This force, we call it adhesive force. I'll take of an example. We have water in a glass. As we know, liquids do not have shapes. So whenever you take a liquid and pour it in a shape in a container, the liquid is going to occupy and take the shape of the container. Now for the liquid to remain inside that particular container, the molecules of the liquid, there is a force attracting these molecules to each other. And we said that that force is a cohesive force. But as well, there is a force attracting these molecules of the liquid, those molecules which are closer to the surface of this container, to the surface of the container. The container is a solid, it has got particles in it. So a force of attraction between the molecules of water and the molecules of the container or the molecules of the surface, we call it adhesive force. A force of attraction between molecules of different kinds. And that tells us that these forces of attraction is the one which will cause a liquid to be on a certain surface. For a liquid to be on a certain surface, the molecules of that liquid must be attracted to the molecules of the surface. And the force attracting these molecules together, it is a force we are calling adhesive force. So cohesive forces is a force of attraction between molecules of the same kind. Adhesive forces are forces of attraction between molecules of different kind. I've used an example here of an attraction between a water molecule and another water molecule. Here we are talking of an attraction between a water molecule and the surface of the container in which the water has been placed. Maybe a glass molecule and a water molecule. The two are attracted together. For the liquid to remain in that container, there must be an attraction. For the liquid to wet a given surface, there must be an attraction between that liquid and the surface. And that attraction results from the forces which is attracting these molecules of the liquid and the molecules of the surface. So that is the difference between a cohesive force and adhesive force. Now let's proceed and look at experiments which try to demonstrate or differentiate these two types of forces. And this experiment is an experiment to investigate the behavior of water on different surfaces. The behavior of water on different surfaces. Now we want to consider two surfaces which are different surfaces. A clean glass surface and another glass surface. But now this glass surface, we want to wax it. We apply some wax on the surface. That is a waxed glass surface. So this is a clean glass slide. Let's call it a glass slide. And this one, a waxed glass slide. So some wax has been applied on the glass surface. So if we take water and pour on these two surfaces, what is the difference in the observation we are going to make? If you take water and pour on this glass slide, this is what you are going to observe. From the diagram, this is a water layer, and these are water drops, water droplets. So on a clean glass slide, we can notice something, that water covers the glass surface. In other words, the glass surface gets wet, completely covered with water, forming a water layer on the surface of the glass. But in the second case, where we have the waxed surface, you find that the water will not cover the whole surface, but the water forms droplets, drops of water. They form on top of the wax surface. Now, what brings the difference between these two diagrams, between these two observations we are making here? On our first diagram, we can see that water is actually covering the entire surface of the glass side. But here we are seeing that water is forming droplets on the surface of the wax. The difference comes in terms of the two forces we are calling cohesive forces and adhesive force. In the first diagram A, the water wets the surface or covers the surface of the glass completely because there exists a strong force which is attracting the molecules of water to the molecules of the glass surface. And that force, we call it adhesive force, a force of attraction between molecules of different kind. So molecules of water are being attracted to the molecules of the glass by a strong force. And this force is adhesive force. So in the first case, there exists a strong adhesive force compared to the cohesive force. So we say adhesive force between the glass molecules and the water molecules is stronger compared to the cohesive forces between the water molecules. In diagram 2, the opposite happens. The force of attraction between the water molecules and the wax molecules is weak compared to the force of attraction between the individual water molecules. So you find that the water molecules themselves, they are being attracted more to themselves. There is a force attracting them closer to each other. So they form balls or round droplets than the force which is attracting the molecules of water to the surface of the wax. In other words, to the molecules of the wax. So in our second diagram, we shall say there is a strong force of attraction between the molecules of water compared to the force of attraction between the molecules of water and the wax molecules. In summary, we say observations. Observations in diagram A. What we observe, water wets the glass surface. While in diagram B, our observation is water forms round droplets on the wax surface. Therefore, explanation, what is causing this formation of droplets and wetting of the surface? Why is it so? A, the water wets the glass surface because the cohesive force, the adhesive force, the adhesive forces between the water molecules and the glass molecules is stronger than the cohesive forces between the water molecules. That is an explanation. That is a reason as to why the water is able to wet the glass surface. Water wets a surface. Water wets a glass surface because of a stronger adhesive force than the cohesive force. The adhesive force is the forces of attraction between the molecules of the glass and the molecules of the water. Here, there exists a weak adhesive force between the molecules of the glass, the molecules of the wax, and the molecules of water. Part B, our explanation to the observations we made in part B. In part B, we say the cohesive force between the water molecules, the cohesive force between the water molecules is stronger than the adhesive forces between the water molecules and the wax molecules. That is our first demonstration, our first experiment, which is showing how cohesive and adhesive cohesive and adhesive forces act. The same thing can happen when you take Vaseline just after you had your bath, a very good shower. Then now you want to freshen your body. You apply your small jelly on your body or your skin. Be it Vaseline, you apply Vaseline on your skin. And try to go to your tap and open the tap and run some water on your skin. You will find that the water running on your skin will form droplets, round droplets, oval droplets on the surface of your skin. And the reason, the explanation is still the same case here, where we are talking of there is a high cohesive force between the water molecules than the adhesive forces between the water molecules and the Vaseline molecules. Now, what about now, instead of using water, we change our liquid. Now we are using another liquid, mercury. Let's use mercury. Using mercury, we have a clean glass surface, clean glass slide, but now we are using mercury. We take mercury and pour some mercury on the surface of the glass. What are we going to observe? We shall observe something, that on the surface of the glass, we shall have formation of drops of mercury. But there is a difference in terms of how the mercury drops looks like. If you look keenly, I've drawn some 2 drops here. Droplets. They are balls made of mercury. This is mercury on the surface of the glass. So you'll find that if mercury is placed on a clean glass slide, the mercury is not going to wet the glass surface. Mercury is going to form drops. And the difference is we shall have formation of big oval-shaped drops. And there are the small round-shaped drops. So what is the difference here? We say that large mercury drops form oval balls, while small mercury drops form round balls. And the reason, the explanation is the same here. We talk of having a high cohesive force between the mercury molecules and a weak adhesive force between the mercury molecules and the glass surface. So, observation here, large mercury drops forms oval drops, while small mercury drops forms round drops. The reason, explanation, what we say, there is a high cohesive force than the adhesive force. You understand when I talk of cohesive force, what am I referring to? An attraction between molecules of the same kind. In this case, we are talking of the attraction between the molecules of mercury themselves. When I talk of adhesive forces here, we are referring to the attraction between the molecules of mercury and the surface molecules. So when there is a high cohesive force than adhesive force, we don't expect the surface to be wet. We expect formation of droplets. So we are going to have formation of droplets. But the difference here and here, we can see clearly. In water, all the drops were round drops. When we use mercury, we have formation of 2 types of shapes. We have the oval-shaped drops and the round drops. The round drops, those are small mercury drops. If the drops are big, then they form an oval shape. So that is how cohesive and adhesive forces act. We move to the second experiment, where again we want to discuss cohesive and adhesive forces in action. In this experiment, we want to demonstrate cohesive and adhesive forces of liquids in narrow tubes. Experiment demonstrating cohesive and adhesive forces, cohesive and adhesive forces of liquids in narrow tubes. Now this one is another symbol experiment which you can as well demonstrate at home. We are going to use a basin. We need a basin or a beaker, and then we need narrow tubes of different sizes. So a beaker, we fill this beaker with water, half full. Fill the beaker with water, half full. This is a beaker half full of water. And then you can observe something. There is what you are calling a meniscus. We discussed a meniscus in our previous topic about measurements. And we said we have two types of meniscus. We have a concave meniscus and we have a convex meniscus. A concave meniscus is formed in liquids which are of less density. Concave meniscus formed by liquids of less density. Which liquids are we talking about? An example of such a liquid is water. A concave meniscus is a meniscus which curves upwards. As you look at the surface, at the edges here, the liquid seems to be curving towards the surface of the container, the beaker. Meaning, it shows that the liquid is more attracted to the surface of the container. And the attraction of the liquid to the surface of the container is as a result of a force of attraction between the glass molecules and the liquid molecules. So this shows what? There is a force of attraction. There is more attraction between the molecules of the liquid to the molecules of the container. Now, we say in this experiment we need two tubes. So we take two narrow tubes and dip them. We dip the two tubes in the beaker containing water. The tubes are of different sizes. We have a narrow tube and one which is a bit wider. A narrow tube and a little bit wider tube. The tubes, we dip them inside the beaker of water. Then we leave the setup for some time. This is a beaker. It's containing water. After some time, there is something we are going to observe. You will find out that the liquid rises up through the tubes. The liquid rises up the tubes, both in the wider tube and in the narrow tube. But there's a difference we are going to note, that in the narrower tube, the liquid rises more higher. The liquid level is higher than the liquid in the wider tube. That is the main observation we need to note, that the liquid rises higher in the narrower tube than in the wider tube. Now, what is causing the liquid to rise up? Likewise, when you look at the meniscus, it is a concave type of meniscus. A concave type of meniscus, we say it is a meniscus where the liquid curves upwards. The liquid curving upwards on the surface indicates that there is more attraction between the molecules of the liquid and the surface molecules compared to whatever is attracting molecules to themselves. That is cohesive force. Now, our observation in this experiment is the level of water inside the tube is higher than outside the tube. That is also an observation we can see, that the liquid has risen above. The liquid has risen above. One observation is the level is higher in the narrow tube compared to the wider tube. Likewise, the liquid levels in both tubes is above the level in the beaker. So the liquid levels inside the tubes is higher than the level outside the tube. So we have two observations. There are common questions you will meet when you are being told the diagram is drawn, a student was trying to demonstrate cohesive and adhesive forces, then you are told, state two observations he made. Remember a question asking you to state the observation. Observations is what you can see, what you can feel, what you can taste. That is if an experiment you are testing something. But in this case, we are talking of the observation you are going to make. The observation is, what are you going to see? There are two observations we are going to note. One, the liquid rises in the narrow tube above the level of the liquid outside the tube. The water level in the tubes is higher than the water level outside the tubes. Number one. Number two, the water level is higher in the narrower tube compared to the level in the wider tube. Those are the observations we made. Now, what is causing this? Another observation, I might insist on this one, is the meniscus. Always we forget about this one, the meniscus. When you look at the way the water is curving upwards, forming what I called a concave meniscus. Concave meniscus. Meniscus is formation of a concave meniscus. In other words, the water seems to be curving upwards. Now, what is causing this? Why is the water rising up the tube? Why is the level of the liquid higher in both tubes compared to the level outside? It is caused by the cohesive and adhesive forces. Here we have more adhesive force than cohesive force. So the molecules of the water, they are experiencing a force of attraction more to the container compared to within themselves. There is a high attraction, a great force of attraction between the molecules of the water and the molecules of the glass tubes. So there is high adhesive force than cohesive force. The liquid molecules, they are more attracted to the glass surface. That is why they try to rise up the glass, because of the force which is attracting them. And the force is originating from the molecules of the liquid, they are being attracted to the molecules of the glass tube or the surface, container surface. So the force attracting a liquid, the molecules of the liquid to themselves is weak. So you must know that explanation and be able to explain it in the best way possible. So there are so many questions you might be asked about the adhesive forces and cohesive forces. One, you must be able to differentiate between a cohesive force and an adhesive force. We have given a very brief definition, a very simple difference, which you can remember easily. That cohesive force, forces of attraction between molecules of the same kind. Adhesive force, forces of attraction between molecules of different kind. And I've given an example. When I talk of same kind, molecule of a water molecule, another water molecule, that is a force of attraction. These are similar molecules. A water molecule and a glass molecule, these are different molecules. That force attracting a different molecule to another different molecule, that is adhesive force. So there is a difference between cohesive force and adhesive force. You must know these experiments we have discussed, experiments which are trying to demonstrate cohesive force and adhesive forces. Water wets a glass surface, or water wets a surface because of greater adhesive force than cohesive force. When you are mopping or dusting the floor, cleaning the floor using water, the water will wet the surface because there is more attraction of forces between the water molecules and the surface molecules, and that is adhesive. Now, that brings us to the end of our fourth type of force, that is cohesive and adhesive force. We shall move to the fourth type of force, that is frictional force. Frictional force. Frictional force. Frictional force is another type of force. It falls under the category of forces called contact forces. I gave the difference between contact and non-contact force. Frictional force falls under contact forces. This is a force which will act when bodies are in contact. I use an example of rubbing my hands against each other. You find that it is somehow difficult to move the hand past each other, because there is a force trying to oppose the movement of one hand against the other. And that force is friction force. And that force, it is acting because my bodies are in contact, my hands are in contact. It is a contact force. Now, what is friction force? A simple definition of friction force is, we say, it is a force that opposes relative motion, a force that opposes relative motion, a force which opposes relative motion. To oppose is to go against. Motion is change of position. When two objects are in contact and one is trying to move against each other, a force which is going to go against the movement is what you're calling friction force. Friction force causes objects to slow down. My hand finds it difficult. It becomes very difficult for me to move the hand against each other. And that is because of friction. Now, what causes this friction? What causes friction? The cause of friction. There are two things which cause friction force. Number one, we have what we call interlocking of the surface molecules. Interlocking of the surface molecules. Interlocking of the surface molecules. What do we mean by interlocking of the surface molecules? If you observe your hand keenly, it seems to be smooth. Using your naked eyes, you can see your hand seems to be very smooth. But when you take a microscope, a very strong microscope, and observe the surface of your skin, the surface of your palm, you find that the surface of your palm looks like hills, having depressions and protrusions. A protrusion, a depression, a protrusion, a depression. That is how the surface of your hand looks like. In other words, the hand surface looks very rough. Now, what causes the hand to look like having hills and depressions? It is because of the molecules. We have said that matter contains particles. And the particles, in this case, we are talking of the molecules. So what happens is, the surface molecules looks like this. That is a surface. Where here, this is a molecule which seems to be a little bit raised compared to a molecule here. So those are molecules in a body. So on the surface, we have that kind of surface, where some molecules seems to be more protruding to the surface. Others seems to be pushed down. So that makes the surface to look very rough. So now, if I bring another surface in contact with this surface, we shall have this kind of so we have molecules protruding, those are protruding molecules. Then we have molecules that are lying deep beyond the surface, deep below the surface. So a surface, my hand surface, has molecules of that kind. We have those ones which are raised above, others are pushed down. The same with this hand. So when I bring my hands in contact, what happens is we have interlocking of those protruding molecules. And you find out that if I'm trying to move my hand against the other, then some work has to be done to make sure that this molecule passes here. And that work done constitutes what we are calling friction force. So when the surfaces are now brought in contact, we have interlocking. Interlocking is to overlap, to interlock. These are surface molecules, protruding surface molecules. These are molecules which are pushed down underground. So when I bring my surfaces in contact, this is what happens. And when I'm trying to move the surfaces past each other, then we have this. So I need to apply more force. Work has to be done to make sure that these surfaces move past each other. And that now results into what you're calling a force which is trying to move you to oppose your motion. And what you must remember is this. If I'm moving this surface in that manner, I'm trying to push this surface in that manner, the friction will always act in the opposite direction. That is friction force, acting, opposing the motion of two surfaces in contact. So one, friction is caused by the interlocking of surface molecule. These are surface molecules. When I bring these two hands together, the surface molecules are going to interlock. And when they interlock, work has to be done to make sure that there is movement past each other. And then when that work is done, it results into what you are calling the friction force. Number two, friction force is caused by attraction. Attraction between the four surface molecules. Attraction between the surface molecules. In my previous subtopic, we were talking about cohesive and adhesive force. And I said there is an attraction between molecules of the same kind, that is cohesive forces. And a force of attraction between molecules of different kind, that is adhesive forces. So this is my hand containing molecules. This is another hand containing molecules. These are molecules of the same kind. Therefore, there exists a force which will always pull them towards each other, a force which will try to attract them together. Now, these forces attracting molecules to each other, they will cause friction. Why? Because now, if I'm trying to move my hand past each other, and the forces, the molecules, the surface molecules are being attracted to each other, then I have to do some work to make sure now the hand moves past each other. So whenever work has to be done to make sure the hand is moving against each other, it results into what we are calling friction force. So friction force is caused by two things. Number one, interlocking of the surface molecules. Number two, the attraction between the surface molecules. Which attraction? The cohesive forces, which is attracting the surface molecules to each other. Now, when you progress with physics, in the next level, when you get to Form 3, you'll learn about friction in details, where we shall learn about the types of friction. We shall learn about the types of friction in Form 3. But a simple demonstration here. This is an eraser or a duster. The duster is placed, I place it on a surface, my table surface. Now, I want to push the duster so that it moves. We have learned that a force is a push or a pull. When I start pushing the duster, I'm applying a force to push it. You find that my initial push on the duster does not make it to move. I'm trying to push, but the duster is not moving. But as I keep on pushing, it reaches a point where now the duster starts moving. The same will apply to this table. When I push the table, it is not moving at this time, and I'm exerting a force on it. But if I keep on pushing, it reaches a point now the desk starts moving. So what is causing the desk not to move initially? It is because of friction force. There exists friction force, a force which is trying to oppose my motion. And the friction force will always act in the opposite direction, trying to counter what you are doing, trying to go against your action on an object. So friction force always opposes motion. and it goes against the work we are trying to do on an object, trying to push an object, it goes against. So for me to be able to push this desk so that it starts moving, I have to exert a force which is going to go against or to counter or to overcome the friction force on the desk and the surface. So friction forces counters or opposes relative motion between surfaces, and it will always act in the opposite direction. There exists friction force in liquids, there exists friction force in gases, and there exists friction force in solids. Now, how does friction force act in liquids? We can carry out a simple demonstration or a simple experiment which is trying to show us that actually even in liquids there exists friction. Experiment demonstrating or investigating friction force in liquids. This is a simple experiment that you can carry out at home. In this experiment, we need 2 measuring cylinders. That is a measuring cylinder. Another measuring cylinder could be identical measuring cylinder. We need 2 identical measuring cylinder. We need 2 ball bearings. We need water and we need glycerin. So we are going to fill these beakers, this measuring cylinder with the 2 liquids. One, we fill it with water to the rim. The other one, we fill it with glycerin. So this is a measuring cylinder. This one contains water, this one contains glycerin. Now, what we are going to do is this. We take the 2 ball bearings and then we release them in the 2 measuring cylinders at the same time. Remember, the ball bearings are identical. The beakers, the measuring cylinders are identical. They have been filled with liquids of the same volume. So we take the 2 ball bearings and release them into the 2 beakers at the same time. And the moment we are releasing them, using a stopwatch, we want to time how long it will take for the ball to move through the liquid to where? To the bottom end of the measuring cylinder. So if you release the balls in the container at the same time, you will find that those are the ball bearings moving through the 2 liquids. There is one ball bearing which reaches the bottom end faster. And which ball bearing is that? Is the ball bearing in water. The ball bearing released in water reaches the bottom end faster compared to the ball bearing in glycerin. Now, what causes the difference? Why are they reaching the bottom end at different times? Yet the volume is the same, the measuring cylinder is the same, the ball bearings are the same size. The difference is in what does each ball bearing encounter as it moves through the liquid. Whenever there is motion, there is a force we are calling friction, which will always try to counter motion. So you find that the 2 ball bearings experiences an opposition to their movement. There is a force which is trying to counter their movement in the liquid. And this force trying to counter or opposing their movement through the liquids is what you are calling the friction in liquids. So the ball bearing in water experiences less friction. The ball bearing in glycerin experiences more friction. So the ball bearing in water reaches the bottom end faster than the ball bearing in glycerin. Now, the friction force in liquids or fluids, we call it viscosity. Viscosity. viscosity, or viscous drag. That is friction force in fluids. The friction force in fluids, we call it viscous drag or viscosity. And this viscous drag or viscosity will always try to limit the speed with which a body moves through. Will always try to limit the speed with which a body moves through a given fluid. So viscosity limits the speed of a body through a fluid. When I refer to a fluid, when I talk of a fluid, I'm not referring to a liquid. A fluid is a general name referring to either liquids or gases, meaning even in gases, there exists friction. Even in gases, there exists friction. An object moving through air will experience an opposition, a force trying to oppose its movement, and the force is friction. We are saying friction force in liquids, friction force in gases, we call it viscosity or viscous drag. Therefore, whenever viscosity is encountered, it will always try to slow down the movement of an object. An object moves down whenever there is friction. It slows down or limits the speed at which an object is moving through a fluid. So these are very simple experiment, very much examinable, a very common question in the exam. The two diagrams will be drawn. Then you're told the student released the two ball bearings at the same time in the two measuring cylinders. And he timed how long it takes for the balls to reach the bottom of the measuring cylinder. Then you're told, state which ball reaches the bottom first. We said the ball bearing in the water reaches the bottom end faster than the ball bearing in glycerin. Then you're told, explain your observation. You'll say, the ball bearing in water experiences less viscosity compared to the ball bearing in glycerin. So you must be well prepared, revise so many questions on that particular type of force, then you'll be in a good position to answer questions to do with friction force. Now, we shall wind up our lesson at that particular time. In our next lesson, we shall be continuing to look at other types of forces, including magnetic force, centripetal force, electrostatic force, and some more other types of forces. Thank you so much, students. Meet you next time.